Have you ever wondered what really separates a good answer from a great one in your GCSE chemistry exam? Well, today, we're going to pull back the curtain and look inside the official AQA mark scheme to find out. You know that feeling, right? You're staring at a question, thinking, what is the magic formula here? What does the examiner actually want me to write? Well, today, we're going to get those answers. We are cracking the code. We are going to take one AQA GCSE chemistry question and completely dissect it to show you the secrets to getting a perfect score. You ready to level up your exam game? Let's do this. All right, let's get into it. We're decoding question 2. And first up, it's all about calculations and data. Okay, so what are we looking at? Here's our first clue. A table showing different alcohols and how much energy they release when they're burned. And you can see a pattern right away, can't you? The bigger the alcohol molecule, the more energy it releases. That's definitely going to be important. So our first challenge is a 2-mark calculation. The question wants to know how much ethanol we need to burn to get the same amount of energy as burning just 1 gram of heptanol. Let's see how it's done. So how do we solve this thing? It's actually pretty straightforward. First, you look at the table and grab the energy value for heptanol. That's 39.8 kilojoules. Then you just divide that by the energy value for ethanol, which is 29.6. And there you have it. The answer is 1.34 grams. But hold on, this is where we get the inside scoop. The mark scheme says, and I'm quoting directly here, they'll allow 1.34459459 grams correctly rounded to at least 2 significant figures. This is a huge tip, guys. Precision matters. A simple rounding error could cost you marks, so pay attention to the details. And speaking of precision, our next job is to plot that data from the table right onto this graph. This is where your accuracy is really going to be put to the test. So what's the examiner looking for? Well, they want all 6 points plotted correctly, and they've got a really tight margin for error. We're talking plus or minus just half a small square. But hey, don't panic. There's a bit of a safety net. You can still grab 1 mark even if you only get 4 or 5 points right. And every single mark counts. All right, now it's time to use the graph we just made. We need to estimate the energy that would be released from octanol, which is the next alcohol in the series with 8 carbon atoms. The mark scheme says the answer is 40.6 kilojoules. But here's the real game changer. It also says they'll allow a value consistent with the plotted points. This is massive. It means even if your graph isn't absolutely perfect, as long as you read your own graph correctly, you can still get the mark. Just make sure you show you're working. Okay, we've flexed our data and graphing muscles. Now it's time for a quick fire check of our pure chemistry knowledge. Let's see what we know. First up, a classic pop quiz question. Lime water is an aqueous solution of what? The answer is calcium hydroxide. That's one of those facts you just have to know. Okay, so what happens when you bubble carbon dioxide through that calcium hydroxide solution? This is the classic test for CO2. What's the result? Now here's another awesome tip from inside the mark scheme. There's more than one right answer. The examiner will accept milky or cloudy. They'll even take a white precipitate is formed, or if you say calcium carbonate is produced. So knowing all your options gives you a much better shot at getting the mark. All right, we've seen how flexible the mark scheme can be. Let's finish up by diving into some organic chemistry. We're talking reactions and structures. So here's a little riddle for you. What do you react with ethanol to make ethanoic acid? The correct answer is an oxidizing agent. That's a fundamental reaction you'll definitely want to have in your back pocket. Time to get a little artistic. The question gives us part of a structure and asks us to complete it. So what's missing? Just a double bond between the carbon and the oxygen up top, and a single bond over to the OH group. And just like that, you've drawn a perfect carboxylic acid functional group. Last but not least, it's a little game of connect the dots, chemistry style. We have to match the reactants to their products. So, ethanoic acid plus ethanol. That connects to ethyl ethanoate. And ethanoic acid plus sodium carbonate. That connects to carbon dioxide, a perfect match. And there we have it. We've taken a deep dive into question 2. We've decoded the mark scheme, and we've found some amazing secrets to exam success. So what have we really learned here? The big takeaways are pretty clear. First, precision is absolutely key. You saw that with the rounding and the graph plotting. Second, remember that sometimes multiple answers can be correct, like with the lime water test. And of course, you've got to know your basic definitions and structures. Ultimately, the mark scheme is your best friend. It's the ultimate guide to what examiners want. So now it's over to you. After getting this peek inside the examiner's playbook, what's the number one thing you're going to do differently on your next exam? Because really, applying these little insights is how you start to get every single mark.